The moderator is Harish Patel. Mr. Patel is the manager of drilling and production for the American Bureau of Shipping. He is responsible for the validation of new technology and the development of requirements for the classification and certification of technology used in marine applications. He has 24 years of experience related to the design of equipment used in the offshore industry. He has a master's in mechanical engineering from Stevens Institute of Technology. Mr. Patel.
Thank you. Thank you and good morning, everybody. And we appreciate the opportunity given by the BSEE to present our view over here, and I'll be moderating this panel for what manufacturing, test, maintenance, and certification requirements should be established to assure the operability and the reliability of the BOP. Like we say, we listen in the morning from Ken Salazar that there is 4 major topics they need to address, and one is how we're going to maintain. We listened to the design side just in the previous panel. When you design something, now you have to manufacture and maintain and operate. So we will be talking about how we're going to manufacture and operate. And this panel represents a wide speaker over here. We have 2 drillers which will bring the operational experience onto the table. And then we have a API also over here, which brings the codes and standards, which will address how to maintain and inspect and test. And then we have a waste engineering. They are the consultant, and they have done a lot of study you heard in the previous one, and we will see their view. So without wasting time, I'll start introducing the first speaker. Our first speaker is Mo Pleasance. He is very well known in the industry over the last 35 years. Mo being involved in the drilling operations, various drilling operations in the various parts of the world. He has drilled various deep water wells also, and he been the member of Board of Governance and Center of the Offshore Safety. He is a member, Board of Director for Offshore Technology Conference, which is going on. He is a member on IADC Executive Committee and a member of IADC Board of Directors. So please welcome Mo for his presentation.
Hello, and contrary to popular opinion, I'm not dead, I'm here, and I haven't retired yet either. So my presentation this morning is going to deal a little bit with, again, with the topic. It's going to look a lot like the new S-53, because that's where we got it from. We had we took part in the 53 rewrite group, and we're very proud of the work that Frank and the rest of the team did. I think it's certainly a great start to where we need to be. Not knowing what we were going to say here, we probably, like I said, it's going to look a lot like 53. We'll talk about a little pre-deployment, during testing, during well operations, inspection, maintenance, again, pre-deployment, and at a specific time frame, 1 to 5 years, certification requirements. Let's talk about pre-deployment. Some of the older rigs are constrained by height, where you can't join the lower marine riser package and the lower BOP package in situ. You have to bring them over to the cellar deck, put them underneath the rotary, and stack them up from there. Now we have been able to do some testing using inflatable packers and some other things, but these are things that we're going to have to define and see when we're testing. And these are the tests, as Dr. McCarthy was saying today. We've done a lot on just pressure testing. We haven't looked at worst case scenarios. We haven't looked at some of the other things that were mentioned today, but I think it's something we can work on. Capability of shear ram and ram operator to be verified with the manufacturer for the planned drill pipe. The sealability, shearability and sealability are extremely important to all of us, and this is why we're here, to talk about it. And our fleet at Diamond Offshore contains everybody's. We have Camerons, we have Hydrill, and we have NOV BOPs. So we're having to work with all the manufacturers to see where we can best meet the requirements as they come down the pike. I was on the first, back then was MMS work group to extend the BOP testing from 7 days, which had been in place since the Santa Barbara issue, to make it 14 days. And we looked at reliability. It was pretty basic reliability issues. We did what Dr. McCarthy said. We got about 1,000 BOP tests, and it painted a very pretty picture. But it wasn't the whole thing stacked up, and all hell was not breaking loose. But I think we can work together and meet those requirements. We think that BOP testing of 21 days and allowing exceptions to that because of issues in the well or issues on the rig, especially safety issues, and those would be handled by a management of change type scenario. We think those are the way to go. We certainly don't want to test with pipe in the hole, because we sure don't want to have a fishing job after that. And we want to test to the smallest OD drill pipe to be utilized in the whole section. Of course, now with variable rams that we're using, one set of variables may cover 3 different pipe sizes that we're using in the hole at the same time. Inspection and maintenance. We believe 100% in the tenets that were put up in 53 about inspection and maintenance. What we want is to have the specifications of what we want to do, and we want the how to be something that we can work out, as we talked about this morning. There's talk about BOPs having to go in completely taking them apart, taking them off the rig. Director Watson at OTC asked me a question, and he said, "Do the BOPs stay with the rig throughout its life?" And I said, "Yes, sir. The BOPs are like my grandfather's axe. It's been on the rig. He's had this axe for 35 years. He's only changed the handle 3 times and the head twice. So takes a little while; it'll sink in." But, we have planned maintenance schedules. We've put replaceable wear pads, wear seals in some of our BOPs. We've done a lot of things that would makes the maintenance much easier. We still meet the requirements. We still meet the maintenance issues. But taking a BOP down is labor intensive. It has safety issues of moving it, getting it into a shop. We infuriate all the drivers that have to drive behind this heavy load, wide vehicle deal, and then we get it into the shop. And by that time, if we have not messed up a ring gasket or a seal face, then it's unbelievable. And of course, then you got a weld repair, which means you got to put it in the oven. And there goes one life cycle out of things. You're closer to not meeting NACE every time you put it into the oven. So there are a lot of issues that we need to look at. It's just not that easy saying, well, you just take it in every time. What about failures in the mid? We have a ready line in New Iberia where we have spare BOPs and spare bonnets, and we can send those out and put them on the rig. And so we've zeroed out that specific component. So I guess what I'm saying here is what was delineated a little earlier. Tell us what you want and let us figure out how to do it. You know, that to me is the most important tenet we're going to get out of getting this done. Again, inspection and maintenance. Is it 1 to 5 years? I think we need to work with the manufacturers to put it down. It shouldn't be prescriptive to the nth degree that we're talking about. So, certification requirements. We worked with the certification requirements with the initial drilling rule. We talked about the certification and verification issues that were put in to allow us to get by and through the moratorium. I don't think any of us here have any problems with meeting all these requirements. I'm sure my CEO would not have liked for me just to say that, but we don't. We do, you know, we can meet these requirements, we can do the things. We just need to be given the time to do it, and we need the time to initiate. Chuck Chauvier, a good friend of mine and everything, and he's got a order book that's more than full. Now, he won't turn us down. You'll take the PO, I'm sure. But we're trying to get all these things done, and we've got to remember that we're building new rigs all over the world. The land rig business is going completely berserk, and the same machines that turn out the big BOPs turn out the land BOPs. So there is a huge factor right now of trying to get our equipment in and getting it worked on and meeting some of these things. So if we can shortcut this and still meet the intent and still meet the requirements, I think that's the way we need to go. That was rather quick, and I didn't go through all of it because I didn't write this, I have to tell you. I've been chasing drilling rigs around the world for 45 years. My dad did it before me, and my grandfather was there before me. I have 4 brothers. All of us worked in the industry. One of them's a geologist, so he's got more money than the rest of us. I love this industry. My son worked in it. This has been a very, very tough couple of years. But I can stand up here and say from a personal point of view and from my company at Diamond Offshore, we want to be part of the solution, and we want to do what's best for our country, for our people, and for the world. We're active all over the world in all the basins of the world, so whatever comes about here is going to influence what goes about over there. So thank you all, and I'll be glad to answer some questions when we get through.
Our next speaker will be John Modin. He is with API. John Modin joined API in 1975, and he is a director of API Global Industry Services. John been in the industry for the last 25 years, and he has a business management degree. He been involved on a various program with API currently, and he been overseeing all the 53 and API 16's development also. And he been involved in the certification program and a training program also. So please welcome John.
Thank you, appreciate it, Harish. And I appreciate this opportunity to get in front of everybody today to give an overview of what we call the API Monogram Program. Several of you probably know about the program, being in the industry, and then also some specific comments on what we're doing about BOPs, certification and licensing for the program. Before I get started, just a little one slide on what Global Industry Services is. We're kind of the independent part of API. We're the part of API that doesn't do any of the lobbying or the advocacy side of what we're known for, at least inside the Beltway. We do the work that we're known for outside the Beltway and around the world, and that's all the training and certifications and standards that we sell and the industry statistics that we put together and the events and conferences that we work on for the industry. My group has got around 60 employees. It kind of changes week to week. We're opening up some new areas now, and we employ we contract with 140 different auditors around the world to do the kind of audits that we need to make sure that manufacturing is done properly and in accordance with API standards. We have an office here, obviously in DC, where our headquarters are, but have offices in Houston and Singapore and Dubai and also in Beijing. And we have a lot of equipment certification, personnel certification programs. And I also today focused my attention on the company-based certifications that we have. And then again, we publish standards and sell those standards, over 600 standards that we maintain, and have been doing it since 1924. We'll put on about 100 different events this year, and also publish 8 different rotating statistics products that are of value to the industry. I'm going to focus my attention on the Monogram program because that's really what we're talking about here today, at least in terms of the certification and verification that manufacturers are making equipment properly in accordance with API standards. The Monogram program has been around since 1924. It started the same year that API started developing standards and started publishing standards. It's changed a lot since that time, of course, but it encompasses most of API's upstream standards. It does include some of the API's downstream or refinery standards, and also some supply chain standards where we're getting the raw materials to make the equipment that goes into making BOPs and things. The idea is to help promote the manufacture of safe, reliable, interchangeable equipment so that when our company's operating anywhere they are around the world, whether it be in the Gulf of Mexico or onshore or in Sakhalin Island, they can choose from a manufacturer that's gone through our process and they've been audited, and they make sure that they can make that equipment in accordance with API standards. We've got about 4,000 licensed facilities now around the world, and about 80% of all the licensees that we have are outside the U.S. As you can see, about 70 different kinds of standards that we do audits for. Of course, the BOPs are included in that. We'll do an audit, depending on the type of facility it is, on an annual basis or up to every 3 years, depending on, again, what kind of license they have with API. And just this year alone, we'll conduct 3,500 audits of manufacturers around the world. So this is it's a massive undertaking to get this work done on an annual basis. Kind of the foundation of the Monogram program is called API Specification Q1. And you guys have all heard, I'm sure, at some point about ISO standards and certification. This takes that standard but builds an extra 41 extra elements on top of that are of particular concern to the oil and gas industry. This standard is maintained by a committee, one of API's hundreds of committees that we have to maintain our standards. And the committee is made up of the manufacturers, the oil companies, the various auditors, the people that have experience with quality management systems and manufacturing of equipment. I know we made, Director Watts had mentioned earlier today about how we needed to have stricter controls over how we operate offshore, and actually that's one of the things that Q1 does. It goes above and beyond the ISO standards, and it actually requires, has extra controls for the prevention and use of non-conforming equipment. It requires annual management reviews and internal audits. And then it's, as you can see, I won't read all of those extra controls, but these are extra controls above and beyond the ISO standards that again, our committee finds that are relevant and that are needed to make sure we've got the right controls and necessary to make equipment for the industry. And you'll see there's a laundry list of things that seemingly are very important for the manufacturing of equipment. What does the monogram mean at the end of the day? Well, we're providing a license to a manufacturer to actually stamp that logo into the side of equipment or on nameplates on equipment. And that logo is a warranty, a guarantee to API and the buyer that that piece of equipment has been made in accordance with the standard and that it's guaranteed to meet every minimum requirement of that standard. So a licensee can only use that mark on the side of equipment if they've been audited to make sure their management systems meet Q1, that they've proven to API through our audits that they have the capability to manufacture equipment into the standard that they've been provided a license for. They can only use it on equipment that meets all the standards requirements. The real important part of this is for buyers especially. People tend to think of buyers just being oil and gas companies, owners and operators, but frankly, some of the largest buyers of manufacturing equipment are other manufacturers, large manufacturers. So go to the composite list. That's what we call basically our directory of all the certified manufacturers around the world. The hard copy version is as obsolete as the next day. The real-time version is the one that's online, and that's the real useful version. These are the various series of standards that we cover. I'm not going to read all of these, but as you can see, each one of these series actually has a subset of other standards that help make up the various 70 to 80 different standards that we cover. Of course, what we're talking about today is the blowout preventers, and under that is what we call the Series 16 series standards. You've heard mentioned several of those today already, and that's where 16A sits under our drilling well control system standard series. In general here, just a brief review of how you go through the licensing process. You go through an application review. On the left there, you'll see the various things that are required by API before we can get the process started. And we'll work back and forth with the manufacturer until they've got that application in-house and proper. We'll do a document review to make sure that their document requires them to ensure that they're going to meet all of our Q1 expectations and the specifications that they're going to be licensed to before we spend any time and energy on site. One of the things that we do spend a lot of time in, and especially I've been with API now for 17 years, and we've done an incredible job here in the last 6, 7, 8 years of improving the types of auditors that we use, the kinds of experiences that we need. And so we make sure that we select auditors that have the background, that have, in this case, offshore drilling background, blowout preventer, manufacturing kind of background to send out to do audits. The audits will be a team of auditors, typically a two-man team for 5, 6 days, depending on the type of license that they have. So it'll be a 10 to 12-day audit. We'll go through the audit and make sure that all the nonconformances, if any, are completed. We have an online system that is convenient for any of the manufacturers around the world to utilize. And then after they've proved to us that they've met all the license agreement requirements, the Monogram Program requirements, Q1 requirements, and the product spec requirements, we'll issue them with a license. A few comments on the licensing of blowout preventers. We license BOP manufacturers, repairers, and remanufacturers under 16A up into the 3rd edition of 16A. In March 12, 2007, we decided to withdraw the ability to apply for a repair and remanufacturing license. They were withdrawn under API's administrative concerns with what was going on with the repair remanufacture licensees. One of the requirements that we had at the time was to make sure that the repair remanufacture licensees had access to the original equipment manufacturer's designs. And it should come to no surprise that that was a difficult thing for us to mandate and for them to get access to. So really based on that very critical element, we decided, look, there weren't adequate controls in place for us to feel comfortable in issuing licenses in this area. So we withdrew that. And we do obviously continue to license new manufacturing, but no repair remanufacture. We talked about the new standard that obviously is being built. The standard 53, first ballot went out June 14th, closed on the 29th of last year. Second ballot was later in last year to just close this year in January. And then we got a final resolution scheduled for May 18th, which just got finished doing. And the major issues that were outstanding were allowance of risk assessment in lieu of the requirements for two blind ram shears. We need to reach consensus on the requirement for auto shear and dead man system, and an option to allow the operator to use their internal exception process to deviate from the standard. So we're trying to work these issues out. I know that last week we also, not only did we have a meeting about the the standard 53, but we also had our first meeting on API specification, well, what could be specification 16AR, or maybe it could be recommended practices AR, but that's going to be addressing blowout preventer, repair, remanufacture. And I know there was about 60 to 70 people in attendance, so it's going to be a hotly contested, interested group working on that. And so don't know what the outcome of that's going to be. We got a long way to go until we get to that point, but we may get into after the publication of that document to where API is more comfortable in doing licensing back to repair, remanufacture, because that's a very important part of this game. So anyway, I appreciate your time and thank you. I'll be happy to take questions at the end of our conversation.
Thank you, John, for nice information on the manufacturing and quality control. Our next speaker will be Don Jacobson. He is Senior Vice President in Industry and Government Affairs at Noble Corporation. Don is an industry veteran over the last 30 plus years. He held various positions with Hayes Corporation, Shell Corporation, and Noble. And Don is governing board, member on the Offshore Energy Safety Advisory Committee, which is chartered by U.S. Secretary of Interior Ken Salazar, and they advise Ken Salazar, so he's one of the key members. He is also a member of the Offshore Safety Center in Houston. So please welcome Don.
Thank you. Thanks a lot. Happy to be here, and thanks for BSEE to organize this. I ask you, Doug, next time a little more advance notice would be helpful, but we're happy to contribute. I've just got a handful of slides. One is my get out of jail card, but I think today's challenge, and you saw what we're going to talk about: manufacturing, maintenance, and certification. And I'll try to touch a little bit on all three, but leave a lot of the certification comments to Jeff, who will follow me. And I think before getting into it, you heard from the previous panel, and we've got a panel coming up after lunch about what can we do, new designs. You know, we've got a pretty complicated kit already. And, you know, Tom Hunter asked that we make it reliable, self-assessing, repeatable, upgradable, repairable, understandable, and affordable. So we've got a task ahead of us. So I think some of the comments from the previous panel about defining what we want it to do and be specific about the function is critically important, because this is complicated kit. As far as manufacture, really would be good to have a equipment manufacturer up here to talk about it, but I think I'll just make a couple of comments. One, you heard about API standards. We got compliance to API standards. You know, we support that 100%. Deputy Secretary Hayes talked earlier asked a question about how do we do this together. Well, we have the API work groups to really work this, and we've got to make use of that. I think the next point's about during manufacture being really robust on QA, QC, about testing material specifications, factory acceptance testing. If you look at the nuclear Navy, the Subsea program and the success of that is that one of the tenets of that program is really focusing on this QA, QC and making sure they've got the right materials and the right manufacturing. And then certainly certification and thorough documentation, and that's initial certification, but as I get into the maintenance aspect, it's important to maintain that. Now, I agree with Mo on API Standard 53. We support that, and our maintenance program and policies and maintenance programs are really dovetail in with the requirements there. We've issued a subsea policy, and the first bullet, you can see that. It's about getting all the planned maintenance between wells, even at the expense of downtime. And the way the industry has progressed is that when we normally have an allotted time for maintenance, and beyond that can be, depending on contract, can be downtime, which means no revenue for the contractors. We think it's important to do this, and I think our contractual situation will catch up. But we're going to put a stake in the ground, and we have to say we're going to do what's required, and make it mandatory. It's not a, you know, we think it's better to do it this way this time and another way, be more prescriptive about it. And it applies to our floating fleet around the world, regardless of jurisdiction. We have issued a subsea standards, and this really specifies what's required in the end-of-well maintenance. And it really is about maintaining that certification of compliance and doing the right 1, 3, 5-year maintenance cycles of our kit. There are a lot of times we want to change something, and customer requirements on different configurations or changing regulations, and we get, being rigorous with the management of change process for that, for system changes. You heard Tom Hunter present a question this morning about, do we understand what the equipment is down at the seafloor? We have to have maintain that documentation, traceability throughout its life. We get specific about what we want to test prior to it. I've got a slide on that. And also, how do we get our management behind it and supporting it and taking ownership for the subsea kit, from the CEO's office down to the subsea engineer on the rig. And part of that is just a rigorous audit program. Pre-deployment testing, and Mo mentioned a number of these things that built into 53. Just to give a little more detail to it, a little more flavor or color to it, doing complete valve testing and all the choke and kill lines, making sure we move and retract, and we've got a number of connectors that move and make sure that they all function. We actually do a visual on ram closure from bottom up. It seems kind of silly. You have to do that just to see them in position. Function. Everything for both pods and both panels. So this takes a lot of time to do that. And then all valving, we make sure that we check them, but we also measure to see that we've got proper functioning and closure. And then, of course, the ROV, we talked about ROV intervention, and I think Chuck had a great slide on some of those things that are being built into the capabilities there. So make sure all those are tested. And this is all before we go wet. And then a rigorous set of pressure testing, testing the rams in closed and blocked positions with the locks energized, and making sure that we've got rigorous tests. So this does take time, and it's something that I don't think the industry is responding to, and this is what we need to do offshore. I think in addition to this, I mentioned all that this, once we get on bottom, we do a set of required testing that's a lot more rigorous than it was before. And I think the industry has done a great job of responding already to what we learned from the Deepwater Horizon event, and some of the standardization of the BOPs, the API Standard 53 work group, and just how the different, both on the operator and contractor side, we've kind of raised our expectations across the industry. Critical to this is people, though, and there's the fifth panel is about training and learning and development. In subsea capabilities, this is a complex. You saw 15,000 parts. They're electro-hydraulic systems. They're complex kit. We need skilled people out there to do it. And it's very unique work, you know, to get, there's periods when the stack is wet where there's some maintenance to do, but then when it comes to surface, it's get after it, there's a lot to do, and so you need a unique individual that really thrives in that kind of environment. So we are seeing, you know, we've had a few experienced people go to some engineering outfits like Jeff's there, but we're bringing on board a number of people, and part of that is just comprehensive training and development. That's in-house training. We go to the suppliers for critical vendor training. We've got improvement plans on each of these guys. There's an ongoing assessment program. I've got a knowledge handbook here about, you know, so our subsea engineers, there's a curriculum that they go through, and it's pretty rigorous, and there's constant testing against their skills and capabilities. And then also to help us train, but also to help the industry, is typically stacks are down and they're wet for long periods at a time. So a crew might see a stack pull, and if they work a hitch, you know, you might have a subsea engineer that doesn't see a stack pull for a year. So we actually have hit teams where we go out on every stack pull. We have an additional team that goes in to support that effort. One, it provides training so these guys can fast track their learning because they see a number of stack pulls a year, but also it assures that some of this critical maintenance that is required gets done and gets done thoroughly. So there's a lot of different efforts that are going on there. So I think I'll leave it at that. Yeah. Appreciate the time.
Thank you, Don. A very good presentation. It gives the perspective that how complex these systems are and how many things you need to worry comparing 15 to 20,000 parts. Our next presenter is Jeffrey Stadler from the West Engineering. Jeff is another industry veteran. He been working in this industry over 30 plus years. He been involved in the oil and gas side of the business and various capacity. For last 13 years, he is with the West Engineering, and he is a senior vice president of engineering, looking for the compliance and the control sides of the business. Jeff was also a member of the Joint Industry Task Force after the Macondo on an advisory committee. So please welcome Jeff.
Top performance. Top performers, I think that's what we all want. I think there's it's heartening to me to see the level of agreement that we have here. We've come a long way. We've got a long way to go. One of the things I wanted to do is to challenge you as I speak to think about two things that characterize top performers. First one is consistency, and the second one is measurability. So as I make these comments, think about those two items as I go through there. I may speak more quickly than I normally do because I've got miles to go before I see the 2 minutes that morning. Oops, wrong one, whoops. Quite quickly, we'll look at two different things in my presentation. First, what current status is, and then what issues that I see. Speaking a little bit more to the joint industry project that Dr. McCarthy referenced, you can see here a variety of reliability comparisons of prior studies. There were two studies that I quoted here, the SINTEF 4, SINTEF 2 Deepwater, that both measured mean time to failure, and as well as the JIP that was including data from almost all wells that were drilled in the 2004 to 2006 timeframe. You can see here a tremendous increase in the mean time to failure. Although I agree with Dr. McCarthy that these represent some best case scenarios in terms of failures, at the same time they do represent that our standard testing has resulted in much more reliable equipment. I would think, though, a more critical parameter here is the variance in that mean time to failure on a rig-by-rig basis. First, I'd like to point out the note at the bottom that shows 35% of the rigs that were in the study showed no associated failures at all in the time frame. So that's 3 years that they operated drilling wells and had no reported subsea failures. The flip side of that is if you look at the range of those that did have failures, you can see mean time to failure somewhere between, on the high side, 850 days, down to the low side of 50 or so. That's a huge number. The study was originally designed to investigate what those reasons were. But based on the fact that we thought that the record keeping was in some cases suspect, being that they were as much as 5 or 6 years old, we thought and didn't prove, based on statistics, that it was largely dependent on the people. On the current status, we'll look at the existing standards. Obviously, we've got class as an existing standard, technical class. We've got API that Mr. Modine referenced before, also in the area of specifications as well as recommended practices, primarily for operations and maintenance. We've also got private standards, and I'll get to these in just a second, if you will, and finally the regulatory standards. And of course, we've seen a number of times here, these are all generally considered minimum standards. The reason I bring up these different standards is because each of them can play a part in the current compliance and verification regime. Specifically, who verifies compliance? Each of those parties that I mentioned are capable and recognized as able to provide verification according to the current regulations. I think that there are some particular problems with that. As an example, if you look at the focus of historical focus, shall I say, of class societies, they've been more focused with understanding the ability to do pressure containment, as well as failures for load and that sort of thing. If you get a vessel classed as acceptable to a given class society, it doesn't tell you that they can move from one place to another. It just says that they can comply with standards that they're not fitness for purpose standards. Also in the compliance, there's a clause that we fit into as a registered professional engineering company. The selection of the verifier depends very much so on the licensee, the operator. And as a professional engineering registered company, one might imagine that a company registered in New York City that's doing elevator inspections, at least by the letter of the law, would be deemed to be qualified under the existing legislation. I take that as a ludicrous example intentionally. So that relates to the competence requirements buried in there. And the bigger question is, how often is this going to need to be done? I'm not going to cover that in standards here right now. People are required to verify the BOP for every well. So one of the things I'll mention, and I'll mention only briefly here, West's verification standard was developed as a result of the procedures that have been in formation over the last 26 years. We put together those specifications that are job specific, that relate to regulations, standards, and best industry practices. The big step for us is to decide what's mandatory. For most of those 26 years, we have been hired as a result of our clients' desire or recognition that they provided a value-added service to help them in achieving their objectives. However, once it came time to be a verifier, we had to decide internally what is mandatory, and that wasn't a simple process. One of the things that I've heard a number of times, and I agree wholeheartedly with, is a need to consider BOPs as a system, and that we think that that includes controls, both electronic and hydraulic, and all of the people who are providing verification, I do not think, provide that same system assurance. One of the key things for regulators, I think, is to think about unintended consequences. I'll offer a few that have been discussed that I'm aware of. First of all is the consideration of reduced redundancy. Everybody likes redundancy, everybody likes more than one. At the same time, the question that we should address is the fact that the industry has embraced, as a result of the commercial agreements between the equipment owners and the people that use that equipment, is that we have always had, at least in recent, for a long time, provided equipment that as much as exceeds the requirements. And let me give a specific example. It's unusual to see a BOP stack today working subsea that doesn't have two annulars. There are some that do have, but the norm, I think, is two annulars. Only one is required everywhere, anywhere, in any regulations. There is a bit of a climate out in offshore today that starts from a supposition that if you have the equipment, it must work. And so with that idea, we have doubled the need to pull the BOP, which is in itself a risky operation, if we have one of the two annular BOPs that doesn't work. So let's keep in mind the possibility that people will move towards reduced redundancy as a result as an unintended consequences. People want to talk about more testing. More testing in general is good. I think if you look at the reliability engineering concept, it suggests more testing equals more reliability. The caveat there is the assumption that testing in and of itself is not deleterious on equipment. Although I'm unaware of any studies that have been done about the deteriorating effect of testing, it's generally agreed in the industry that it hurts the equipment to continue to test it. And we're doing a lot more testing than we have historically done. One of the good things, I think, is we've had a bit of an increased focus on repair work, specifically in the non-floater regime. Now, on the issues I'm going to cover quite quickly, I'm not going to give answers, but rather simply ask questions. I've been accused of many things, but not having opinion is not one of them. So what I'll do is I'll ask those questions and look for you to follow up on those. Offer some considerations, and again, leave the answer to you. We talked about manufacturing standards and the fact that they are minimum requirements. The way they are developed involves necessarily compromises. And one of the key issues, why do we have standards, is so that when you purchase something, you know that it's going to be consistent in meeting those minimum standards. At the same time, as time passes, we all recognize that there are gaps. And there is language in there that allows for technology advances, which I think is critical. However, at the same time, there's no commentary about how you evaluate that technology advance, and it's left to the parties in question to make the statement that this is an improved technology. There's no real vetting of that against the standard. Talk a little bit about maintenance systems. There's always a discussion about whether it's centralized or decentralized. The key thing there, I think the industry historically has always desired to put the accountability and responsibility down to the rig manager level. One of the things that results from that, or can result, is that you have a group of experts within, subject matter experts within a given technology making recommendations to the field that may or may not be implemented based on other criteria of the decision makers. So there's an issue about control as it relates to the maintenance activity versus optimization on a fleet level basis. And I'd like to restate that in a different way with the question, how many best ways are there to maintain a given piece of equipment? The second thing that we addressed really with the idea of simple is more better, is more better. That was one of the things that was a consistent message post-Macondo. Let's do more of this, more of this, more of that. It certainly doesn't keep with the idea of keeping it simple and understandable. We talked about repair. There is not a repair standard. There was developed a 16 AR at one point that was not passed and withdrew. As John mentioned, it's being resurfaced. That addresses remanufacturers. Question here is, can the original equipment manufacturer change? And if so, what are the criteria for that remanufacturer? Again, that hopefully will be addressed by 16AR. Similarly, on the parts side, RP 53 talks about equal or better parts. Well, who's to determine equal or better? How about mixing and matching of those parts? Is that acceptable, and under what criteria is that acceptable? How about buyout equipment? I have a regulator here in my hand. It's an OEM piece of equipment if it comes in a bag of a particular marking. It's not an OEM if it's not through that system. I can argue both sides of that case, as if you'd like to talk to me afterwards. Separately, there's an upgrade path. Sometimes there are upgrade equipment that are not available from the OEM. And finally, how about something that's discontinued? So, stop, the sign says, offered many questions, and the answers will vary by providers. Question is, what is the minimum standard, and are we happy about those standards?
Thank you, Jeff. Was a nice view from the third-party certification perspective, and very good questions. I think we're going to have now, we have some time for the question and answer session.
Speaking really personally, rather than just from API, I hope that we do include repair, remanufacture licensing back into the Monogram program. You know, we're working on the standard. It's going to be a while until we get that published. You know, there's really no time frame considering we've just met last Thursday. And I'm no BOP expert. I'm more, but I certainly know that the reality is that we need to have these things repaired, remanufactured, and looked at. And if you're going to mandate testing and maintenance and repair, then we ought to put some language around and requirements around repair and remanufacturing. And it didn't work the last time because of the way that we set it out. We need to make sure that we lay it out where we've got it works for everybody. So, you know, and the only way to do that, I think, at least one effective way to do that, is to then set it under a program where we're going out and verifying their capabilities to do this kind of work, and we're ratcheting up the requirements on even, you know, our licensees, whether it be pulling samples from the shelf, sending it to independent test labs to make sure that they're manufacturing in accordance with the standards, that they're, we need to be ratcheting up the requirements, and so I'm looking forward to the point where we can license to that, and maybe a couple of years before we get to that point.
I guess just to build on Mo's comments, I guess a couple of opportunities we have for feedback is the initial testing and the witnessing learn. Certainly when we do have failures and we're pulling a stack and we're trying to understand, well, we have discussions about, you know, can we operate safely with the conditions of the stack and the components. We've had some good discussions and proactive ones over the last year about, you know, addressing one of the points that Jeff made about redundancy. You know, if we've got a certain valve or a function that's upstream of a critical reliability or closing function, you know, is it safe to operate? We've had some good feedback loops there. And then certainly when we have found issues, either technical or QA, QC, you know, bringing BSEE back in and feeding our learnings back to the organization, that's occurred.
One of the things that I would say...
And you've probably been involved in most of those discussions.
One of the things that I would say is characteristic of the maintenance activities on rigs from our perspective is that you never have too much. I'm not aware of very many discussions where people are happy to reduce the amount of BOP maintenance that is done on rigs. We've done a variety of maintenance studies. I would say almost all of those studies have recommended less maintenance for a variety of reasons. You know, reliability engineering, again, looks at the so-called bathtub curve where we have high failures at the very initial parts. Now, obviously, with better training and vetting of parts and that sort of thing, we can do better. But even with good data, even with good information, there's a great reluctance of people to reduce maintenance as a general thing. And if you can look at the performance of rigs on an individual basis, I've heard the term, the circus game, whack-a-mole. You know, when you get good performance in one area and a bad one in another one, you move some folks around, and the next thing you know, we've got a different poorly performing rig. So we've got a long way to go there, but I think we can do that.
Thank you. Any questions from the floor? I think there's one over there.
Good morning.
Good morning.
Quick question. This is a manufacturing question, I guess. I was wondering, to duplicate the, let's say, 2200 PSI of external pressure at the manufacturer's facility.
Well, we haven't drilled at that depth quite yet.
No, 5,000 feet of water.
That's about 2,500 or so round numbers.
Oh, did I say 25,000?
Yeah, it's about-
2,500, sorry.
Yeah, okay.
That's what I meant, sorry.
That is a problem with hyperbaric testing. Most of the chambers, I think there's one, correct me if I'm wrong, I think there's one in the States that can do hyperbaric testing with significant pieces of equipment. So that's a challenge.
But the whole unit is basically has to operate as a electro-hydraulic, you know, whatever it is, 60 feet high. So I'm assuming that there is no hyperbaric chamber that's big enough to put the whole unit into that type of external pressure.
Not today.
That's correct. One question over there.
Hi, I'm Kent Satterley with Shell, and I'd like to refer to something that Mo said a little bit earlier. He said, tell us what you want and let us figure out how to do it. And I think, Mo, if I can just expand on what I think you were saying, I think what you were saying was don't stifle innovation. Tell us what you'd like us to achieve, and then let us use our capabilities and our technology to solve that problem. You know, part of the purpose of this workshop is obviously to collect information on BOP performance and capability, but I think it's also for BSEE to try to understand what this regulation is supposed to look like and what it's supposed to do. You know, the history of rulemaking, particularly since Mondo, has been rather on the prescriptive side. The problem with prescriptive regulation tends to innovation. To the panel is, how might the regulation look like that and technological advancements in BOPs and well control?
It was well said. I don't know if you do it, but again, define the objective and turn us loose. You know, here we are. We've gone in since my first quote deepwater rig was in 1970, the Ocean Queen, and 600 feet was considered the deepest, and we've progressed now to 12,000 feet over that little bit of time. And we've taken early multiplex systems that we put on. I was building our first DP drill ship in '77, and we put a first generation multiplex system, and we made it work. I guess the key here is there are many ways to skin a cat. I was very fortunate to be in the United Kingdom. I was our area manager in the United Kingdom when the safety case regime started in, and we started seeing the differences between prescription and goal setting performance issues. So we can achieve what everybody wants. Don't box us in too much so that we can ensure that we can get that innovation and we can move ahead where we want to go. Don?
Just to add to that, good question, Kent. I think going back to Tom Hunter mentioned this morning, you know, the government's role is to deal with the what rather than the how. So I think that's what Mo was also reinforcing. And I think, you know, Director Watson has talked about in many public spaces about ramping up the capabilities of the BSEE organization, the technical capabilities, and that's work in progress. So I think there's an opportunity to work together on the defining the what, but there's got to be a strong industry influence into that currently, just from a capability standpoint. And I think you know, being able to, the only way, if we go down a prescription route, and I think that's the point you were making, Kent, is it's very hard to change from that. It's updating those is slow and cumbersome, and will not keep up with technology development. So we have to design a system that specifies what we really need, what the performance criteria is be based on, and then let us, like Mo says, let us get after it and come up with the solutions.
I think in this industry, we have one of the greatest technical challenges of our time in a modern basis. Everybody's talked, if you go to different industry conferences, one of the common themes is people and how we have not very many of them. All these things that we're talking about doing are going to require more people, more technical staff, more trained advanced technology and focus. And I think the issue that we have in order to do that is to understand priorities. We all want to do everything right now, but we simply don't have the staff to do that. So it's particularly difficult then if we go to a performance regime, which is more difficult to understand. Do the right thing. How do I audit against do the right thing?
Any more questions? I think there is one over there.
I would, while you're getting the mic, I would argue though, Jeff, that you know there's a level of definition in the what that it's not a free for all. So
No.
so it's clearly, you know, this is what it needs to do, how, and then I think we could work in that space.
No, I agree. I'm in favor of a performance-based standard because it provides that flexibility and encourages innovation. It's just more difficult to deal with by all parties.
Okay, thank you.
Good morning. Nick Lorette with Noble Energy. I think Jeff had a great point when he talked about testing, the amount of testing we're doing and the impacts that testing is having on the system as a whole. You know, we're doing a 15,000 PSI function test, or actually pressure test on all functionality on the test on the surface. Then we're splashing the stack. We're testing every single functionality again. Every 14 days we're doing a pressure test on every functionality of the stack. And then every 7 days we're testing the functions again. So I guess my question is do we truly understand the impacts that testing's having? And before we pass any more regulation, are we going to put any science behind that testing and how it's impacting reliability of the stacks? Because I can tell you from my experience post-Macondo, we're seeing more test failures. We're seeing more stack pulls. And so what I would deduct from that is that reliability is decreasing. And so going back to what we were saying earlier, yeah, we want to see more functionality out of the stack, but I don't think we've gotten the current stacks right because we're not at 100% reliability. So how can we move forward until we get what we have right?
Thank you. I think that's just a statement you made. Okay.
I don't know. Great question. Yeah. I don't know if any. It's a good. I really can't answer that. I don't know of any plans for a rigorous testing program. It may be something that needs to be mooted a little bit more about, you know, the benefits, how it would be done, what we could get out of that, and how long it would take. Think about it, Jeff.
One of the key issues, I think, I absolutely agree that we need to do some more testing, but one of the panelists earlier talked about the fact that let's keep in mind of how many pieces of equipment of this type are in service today. You go and to buy an electronic component, you can buy it from a number of places. They test them to failure. There's 68 zillion whatever. But the fact of the matter is we're talking about hundreds of pieces of equipment here, a very small universe that makes the statistical analysis very difficult. Not saying that we can't or shouldn't do that. Just we have to keep in mind the reality of the number of the universe of installed equipment that we have.
Okay, I think we got time for one more question.
Rocketdyne. This has to do with requirements. We heard mention of requirements. It ripples through all parts of the life cycle, availability, reliability, and then down to the granular level of every part and system. What suggestions would you have to assure that requirements are traceable into the product, its performance, are verified and validated for the intended function, utility, or some quantifiable value, and are also verified and validated for the worst case scenarios where we might, if you will, try to break the software and see how robust it is?
Okay.
Yeah, we need a manufacturer. Got any valve manufacturers around?
Mel? I think this is more to the manufacturer. They can answer because, in my opinion, drillers are just doing the maintenance per the OEM manuals.
I'll make a stab at that, if you will. One of the things that I think that we could take great steps in improving is the transparency, if you will, in the transfer of information. One of the things that has been particularly problematic of not just BOP but other systems as well is what exactly is equipment designed to do from a controls and software perspective. I think generally speaking, I would characterize what the owner of the equipment receives from the manufacturer, something like the light on your car that says check engine. That's just not acceptable. We can't afford to have a check engine light and then have to figure out what the software is doing. Recently had an issue where the particular manufacturer had a solution to a particular failure mode of automatically evoking an emergency disconnect sequence. I've not met anybody, once they learned of that thought that was a good response to that particular failure mode. What other kinds of things are buried in that software that we don't know about? So I certainly encourage the transparency of information as it relates to the transfer of electrons and making decisions one way and another.
Yeah, thanks. I mean, the thinking is about how you can verify the requirements are addressed. Some of them come down, certification, maintenance, and so forth. But it's hard to see if that's done consistently, and if this is something the drillers will push for, or the OEMs will bring, or it'll be pushed down ultimately by the oil customers. Thank you.
Okay, I think we are running out of time, so we'll conclude our panel over here. And thanks for everybody here, and thanks for participants.